So it's coming, right? Deformation.
Yes.
Deformation, already I told you, it's related to change of shape, change of size, right?
Yes.
So can you please continue the learning outcomes?
State that a force may produce a change in size and shape of a body. Plot, draw and interpret extension load graphs for an elastic solid and describe the associated experimental procedure. Recognize the significance of the term limit of proportionality for an elastic solid, and understanding of the elastic limit is not required. Calculate extensions for an elastic solid using proportionality.
Okay, then continue. Yeah, change of shape. Huh? Continue this one, change of shape.
Change of shape. When a force acts on an object, the object may change shape by bending, stretching, or compressing, or a combination of all three shape changes. However, to change the shape of a stationary object, there must be more than one force acting to do the following: bend an object's end past each other. Example, when an Olympic diver stands on the end of a diving board. A beam is bent, two equal forces act inwards to support left hand end. A third force bends the right hand end downwards. Pull
Mhm.
and pull an object's ends apart. Example, when a rubber band is stretched, a beam is stretched by two equal forces. Beam is thinner in the middle to indicate stretching. Arrows at each end indicate direction of force.
So how the shape is changed, you understood, right?
Yes,
And when there is shape change, we have the volume same. The volume remains same. And now we have some more examples of shape change. Continue this. Yeah, continue this.
push an object's ends together. Example, when an empty drink can is squashed. A beam is squashed by two equal forces. Beam is thicker in the middle to indicate compression. Arrows either endpoint inwards to indicate direction of force. A change in shape is called deformation. Elastic deformation is reserved when force is removed. Inelastic deformation is not reversed when the force is removed. There is a permanent change in shape. A rubber band undergoes elastic deformation when it is stretched when a force is applied, and when it returns to its original shape when the force is removed. A metal rings can undergo inelastic deformation when it is squashed.
Okay, so already we did that part, but change in shape is not changing the volume, right? The volume
Yes,
remains
yes,
fixed.
yes,
But in change in size, we are having volume change. Okay, you understand that when we are inflating a balloon, there
yes,
is change in size. That means volume increases.
yes,
And here we have one sponge. If you are squeezing the sponge, there is change in size. Volume
yes,
decreases, right?
yes, sir.
And now we are having Hooke's law. Yeah. What is Hooke's law? If we are increasing the length by giving some weight, then it follows one rule that
Yes,
extension of the spring or extension of any object is directly proportional to the load. If you are giving too much load, then it's not following that rule. Okay, like maybe after 1 Newton, 2 Newton, 3 Newton, 4 Newton, 5 Newton, it's working. If you are giving 6 Newton, then the extension is not increasing the way it was doing before.
Yes.
So that one is not following the Hooke's law. We are saying that limit as elastic limit. Huh? That the the limit till where the law is working, we are saying that one as elastic limit. Okay, and after that elastic limit, the object or the spring is permanently deformed,
Yes, sir.
and it will not return to its original position again. Is it clear?
Yes, sir.
Okay, that is Hooke's law, and this one we can show with a formula here. F is directly proportional to x. X is the extension, and F is the force applied. Force and weight, same thing, right?
Yes.
And if you write in equation, F equals kx, where k is one proportionality constant and it is known as spring constant. So spring constant, if you want to calculate, you will have force by extension, right?
Yes.
If
Yes,
you
sir.
rearrange the formula, the recording is going on, right?
Yes.
Okay, very good. Then you see, this is when force is measured in newtons, spring constant is measured in Newton per meter, and extension is measured in meter. We have one example. Can you read the example?
A force of 3 Newton is applied to a spring. The spring stretches reversibly by 0.15 meter. The fact that the string stretches reversibly means that it will go back to its original shape after the force has been removed. Calculate the spring constant.
So you can calculate it and tell me the answer. You can do the working here on the screen.
How, sir?
Yeah, you can do it. I allowed you to do. Do the working like you have the also take part in uh, writing annotation, right?
Yes.
So you annotate here, you write in the text you can write, or by drawing you can write the formula. You are going to find the spring constant, so you have to rearrange the formula. K equals F by X. Did you get it?
Yes, sir. The answer is 20
Answer is coming
Newton meter.
20.
Yes.
And the unit is
Newton meter.
Newton meter or Newton per meter.
Newton per meter.
Okay. So answer is 20.
Yes.
Yes, okay. The answer is coming correctly. Then you are having here limit of proportionality. Can you read this part?
Spring constant is a measure of stiffness and strength of a spring. The limit of proportionality refers to the point beyond which Hooke's law is no longer true when stretching a material. The elastic limit of a material is the furthest
Yeah, yeah. Continue.
is the furthest amount it can be stretched or removed without being able to return to its previous shape. Once a material has gone past its elastic limit, its deformation is said to be inelastic.
Okay. So is it clear?
Yes, sir.
If it is within the elastic limit, uh, then if you are removing the weight, then it's going to its previous shape.
Yes,
And if it is crossing the elastic limit, then it will not return. That deformation is called inelastic deformation. Okay.
yes.
Yeah. So this part you can read when an elastic.
When an elastic object is stretched beyond its limit of proportionality elastic limit, the object does not return to its original length when the force is removed. In this instance, the relationship between force and extension changes from being linear or directly proportional to being non-linear.
So after this, we are not having any straight line, right? It's going up.
Yes,
Uh, so sometimes you will be asked to uh, draw how after elastic limit or limit of proportionality the curve is going. You can do it, right?
yes, sir.
Okay. Now the topic is over. It is a very small topic, huh?
Yes, sir.
And you can be able to solve the questions hopefully easily, right?
Yes, sir.
Now I'm uploading these notes, and you have the worksheet also, right?
Yes,
So you can try. You have now some minutes. You can try it. Maybe after
yes,
3 minutes, I will upload. Then you try, huh?
okay, sir.
Okay.
Okay, sir.
Okay. And next class at the beginning we will have the test.
Yes.
Okay.
Topic 4 and 5, right?
Yes, 4 and 5, and you will also resend me the five, the worksheet
Okay,
five,
sir.
huh?
Hmm.
Okay. Thank you.
Allah Hafiz, sir.
Allah Hafiz.